Let's go ahead and build our distance sensors. Mount your microcontroller on your breadboard. Here you have your distance sensor HC-SR04 and its 4 pins. Note that you can use any color jumper wire. Using male-female jumper wires, connect the following: white to VCC, yellow to trig, purple to echo, and gray to ground. Now, let's create a circuit to read an HC-SR04 sensor from our microcontroller. Connect VCC or white cable to the positive power rail. Then, using a red male-male jumper wire, connect the positive power rail to the bat pin on the microcontroller. This connects the VCC on the distance sensor to bat on the microcontroller. Next, connect the ground from the distance sensor to the negative power rail. Using a black male-male jumper wire, connect the ground pin on the microcontroller to the negative power rail. Just like before, this will connect the ground on the distance sensor to the ground on the microcontroller. Then, connect trig or yellow cable to pin 12 on the microcontroller, and echo or purple cable to pin 11 on the microcontroller. Grab the LCD screen and connect 4 female-male jumper cables to the pins in the back. The connection should be black cable to ground, red cable to VCC, orange cable to SDA, and blue cable to SCL. To connect the LCD screen to the breadboard, connect the VCC or red cable to the positive power rail. Connect the ground or black cable to the negative power rail, followed by SDA orange cable to SDA and SCL blue cable to SCL. Insert your button in your breadboard. To connect your button, attach one end of a male-male jumper wire to the negative power rail, and use another male-to-male jumper wire to connect the button to pin 13 on the microcontroller. Double check your connections before connecting to the battery. Insert the battery into the battery holder if you haven't done so already. Insert the red wire of the battery holder to the bat pin on the microcontroller. Then, insert the black wire to the negative power rail.